Good afternoon and welcome to this presentation on Indiana's 3DEP LiDAR data products, accuracy, and access. Our presenters today are Chris Morse at USDA NRCS, Jinha Jung with Purdue University, David Nail with USGS, and Joan Keene with Hamilton County Government and IGIC. My name is Chris Morse, and I am the GIS specialist with the USDA NRCS at the Indianapolis office. Today, I'll be providing a project status update for the 2016 to 2020 LiDAR acquisition for Indiana. This slide shows the project plan on an Indiana map as an overview in its finished form. This project was conducted under 3DEP, which is the 3D elevation program led by USGS. And this program has a goal to complete acquisition of LiDAR data across the country, except for IFSAR data in Alaska, by 2023. This project started as an interagency agreement between NRCS as the principal funder and USGS in 2016, with acquisitions to begin in 2017. NRCS funded approximately $6.6 million into the project, with USGS contributing $159,000 to complete coverage for 89 counties in Indiana, shown here. The counties in pink were doing their own 3DEP projects already to upgrade the vintage and quality of their data in 2016 at the same time as this other planning took place, and were managed separately by those counties. However, they were 3DEP projects and they were completed. The area in northeastern Indiana, shown here on this map, is an NRCS priority from the beginning of the project for the Western Lake Erie Basin. This was a priority for NRCS under the Great Lakes Restoration Initiative, and that's why that option has been called out as the primary product in this project, and it is referred to as the base option throughout this presentation and in general for the project. The remaining eastern counties are option 1 in the State Plain East Zone, and the remaining western counties, State Plain West, are option 2, respectively. The project was developed using USGS LiDAR base specifications 1.2 to help define the requirements, and we will go into detail on those requirements in just a little bit. This project also used the Geospatial Products Services contracts through the USGS National Geospatial Technical Operations Center. So it used GPSC through NGTalk as the lead mechanism for contracting and project management. This is an option under 3DEP that can be utilized. People who submit 3DEP projects do not have to utilize this if they are going to do those tasks on their own and do an RFP and hire a vendor and all of that. However, it does tend to be pretty convenient. It does come with a small fee that goes onto the project. And regardless of whether you use it or not, all data from 3DEP projects must be submitted to USGS for final review and approval in order to be accepted into a data deliverable for 3DEP to meet USGS's requirements to cover the nation with the elevation data that it is mandated to get done by 2023. So using the GPSC process, USGS awarded this project to Wolpert, and that is for those 89 counties we showed on the previous map. Data acquisition began in 2017 and continued each spring since then. Weather delays have extended the original timeline of the project from 2019 to 2020. So let's talk about the technical specifications next. The USGS LiDAR base specification 1.2 was what we were using at the time. It has since been updated, but all the data is still totally valid for current specs as well for the quality levels we are seeking to meet. Generally speaking, LiDAR data uses something called quality level in these base specifications to describe them and the different accuracy levels that they need to achieve to meet those different criteria. And Indiana's old data was quality level 3, and the project that we are currently working on is striving to get Indiana up to quality level 2, or QL2 for short. Generally speaking, the smaller the quality level number, the higher accuracy, the better the LiDAR data. So in addition, quality level is typically defined in terms of point density and vertical accuracy. So with point density, with this data to be quality level 2, we're typically looking for 2 or 2.3 points per square meter. And for vertical accuracy, for the LiDAR data itself, we look in non-vegetated areas. We call that non-vegetated vertical accuracy, or NVA. For QL2, what we are looking for on this chart, as you can see, is 19.6 centimeters or better. All right, and then for the DEM data, we can also check that in terms of NVA, as well as vegetated vertical accuracy, VVA. Again, we are looking for 19.6 centimeters on NVA, and we are looking for 29.4 centimeters or better on DEMs for vegetated vertical accuracy. You can see from this chart that this is quite a step up. The values are about half the size of the threshold values we had for the quality level 3 data in Indiana. So this is quite an improvement in data quality and density we are looking at in Indiana. Moving on, let's talk about the classification scheme of the LAS files, or the point cloud files that are delivered with the project. We did the base classification scheme with no extra classifications ordered. The classifications seen here that you're typically going to get in our project are going to be quality level 1, or sorry, classification 1 and classification 2. Class 1 is unclassified above ground points, and class 2 is the bare earth points. The other classes will appear, but there will be far less of them in our project. Additional classifications, like I said, were not included, mostly due to expense. All right, looking next, there is hydroflattening on the DEM files, or digital elevation model files, that are delivered with this project. This looks at water areas to flatten them for cartographic aesthetics and data quality aesthetics. The water bodies that are greater than or equal to 2 acres and streams that are greater than 100 foot in nominal or typical width along particular reaches where that nominal width is achieved are flattened. They generally flow downhill as well for streams, and an occasional step down wherever the elevation shoreline data warrants that step down. Bridges are also removed, often over these types of streams, as well as over other roadways. And smaller stream channels are not treated in any way. If there's a culvert that crosses a road and there may be a small bridge there, if it's unclear, the default decision is not to cut away the road. So culverts are generally not treated. No additional hydro enforcement, but beyond the 2 acre and 100 foot width and bridge deck removal is done to any of the DEMs. So we can see some examples of this on this hill shaded view of the DEM data. Hill shades, by the way, are not a deliverable, although we have provided it in this example. The impoundment behind the dam, the lake or reservoir, has been flattened. The wide stream coming out of it has been flattened. The stream to the west, that is much smaller, has not, the drainage ditch or stream. Another little drainage ditch along a road that crosses a road intersection does not cut through the intersecting road. So there is not any additional hydro enforcement on this data. And finally, the bridge decks have been removed where it is clear a bridge is present and should be removed. Moving on to deliverables. Point cloud files in LAS format, version 1.4, according to ASPRS standards, will be delivered with the project. In this example screenshot here, you're only seeing about 15% of the points, just because ArcGIS resamples for performance reasons at various scales. You have to zoom in quite a bit to see 100%. Next up, bare earth DEM files, shown here in the raw form without hill shading applied, will be provided in ERDAS Imagine or IMG format, along with hydro break lines that are used in that hydro flattening process in shapefile format will be provided. The tile index will be provided in shapefile format. The tile index matches the state's ortho imagery program, 5,000 by 5,000 foot tiles. Also note here, the DEM files have 2.5 foot pixel resolution in this project, which is a step up from the 5 foot pixel resolution we had in the last Indiana project. Almost 10 years ago now that started, and 7 years ago it finished. Next, intensity files will be delivered in GeoTIFF format. Intensity files capture the strength of the return of the laser pulse. Brighter areas have a stronger return, darker areas have a weaker return. It often ends up looking like imagery. Finally, the data is all being delivered in state plane coordinate systems on NAD 83 with the Harn adjustment, east and west zones, and vertical datum, North American vertical datum 1988 with the GEOID 12B update. So let's talk about acquisition status. The base option area, which is dark green on this map, has been delivered and completed. Back in 2017, it was collected, including metadata delivery in that area. The next kind of medium green area on the east side of the state was mostly collected in 2017 as well. It is also completely acquired and delivered, except for metadata. The west side, the green counties, were flown in 2018 and 2019 and have been delivered without metadata. Knox County, Gibson, Pike, Du Bois County have all been partially completed. Areas in Knox north of this red line have been delivered to NRCS. Areas south of this red line were not able to be collected until spring of 2020. All the data south of this line is in review at USGS right now as of the time of this conference. And we do expect all of that work to be completed this calendar year and delivered along with the metadata for the entire option 1 and option 2 areas, which are kind of just waiting for that last shoe to drop with that last area to be collected. Let's look at a quick metadata example. In the base option, this is just an example. It is not applicable to the option 1 and 2 areas, which we do believe will meet spec. But let's take a look here. Horizontal, coming out of that metadata, has been produced to meet 0.432 meters horizontal. So that's pretty darn good. Vertical, though, is what we're really interested in with LiDAR. On the left, you can see the requirements as we go down through the NVA of the LiDAR points, followed by the NVA and VVA of the DEM. Again, here's the requirements we covered earlier, and the actual results from the metadata. As we check all three of those off, it's looking good. We are within the requirements. Again, these are example values. They will change when we get to option 1 and 2 areas, but we expect them to be delivered within the specifications. Let's change gears and talk about data access and how you can get this data. So this is a 3-step project. All of the data will be made available on the national map after the project is completed. Fortunately, none of the completed work is up there yet. Again, we're still waiting for metadata on option 1 and option 2 areas. So until it's all done, USGS is just holding off on publishing that. But look for it there once the project's all done. IGIC on Dropbox is hosting countywide DEM mosaic files that have been created by NRCS. They're hosting this through Dropbox, but you can access it on igic.org by going to the resources menu and selecting the countywide DEM mosaics option. A map viewer will come up, which is a larger version of what you're seeing in the screenshot here, where you can click on a county, click on the more info link. It will take you to that Dropbox download. Be warned, these files are large. Also, if you have issues accessing Dropbox in your organization, you may have trouble accessing them that way as well. Keep in mind, we did send out a copy of this data to every county government for the counties that have been completed. So you can also check in with them to see if you're in those organizations, if they have this data locally and available for you to start using. Please contact me or Phil Worrell if any of that didn't get out there and if there's any need to make sure that that got in the right hands. Finally, we have a website being hosted out of Purdue graciously by Dr. Jinha Jung, and he's going to talk about that in just a few minutes. Again, you can get to it through the IGIC website using the other link under resources for countywide LiDAR and DEM tiles, or by using the link right here. And right before I turn it over to him, I do want to note that additional options for data hosting are in progress. Discussions are taking place, ideas, brainstorming, and we're looking at all kinds of things, possibly another round of open topography and other options, traditional options that we're used to in the state. It's all still out on the table. Everyone is still interested in figuring out how to make it all work. And once we know more about where things may land, we will gladly share that information. For For now, these are the two options that are primary. USGS will also have it online eventually, and NRCS may have some options eventually as well. But for now, with that, I would like to turn it over to Jinha to do an overview and demonstration of the site that he's been hosting at Purdue to get at some of these raw data products. So thank you for your time today, and take it away, Jinha.
Hello everyone, my name is Jinha Jung. I'm an assistant professor in the Lai School of Civil Engineering at Purdue University. Today, I will talk about the Indiana statewide LiDAR data portal that my research group has been developing, and I will also demonstrate how you can use the data portal to visualize and download the Indiana statewide LiDAR data for your applications. Before I start to talk about the Indiana statewide LiDAR data portal, let me first talk about different data product of the LiDAR data. Level 0 data product refers to the data initially recorded during the data collection stage, and these data products include GPS and INSS and LiDAR ranges. In some cases, LiDAR data collection is accompanied with optical images as well. Level 1 data products are ones generated from the Level 0 data product, and GPS and INSS and LiDAR ranges are combined together to generate the 3D point cloud data. When we also have optical images being collected, and this GPS and INSS data is combined with optical images and other photogrammetric techniques to generate orthomosaics. Level 2 data products are generated from the Level 1 data product, and these products usually include digital surface model and digital terrain model, and we call normalized digital height model, which represent height above ground that is usually calculated by subtracting this digital terrain model from this digital surface model. When we have optical images being collected, we can also generate different vegetation indices such as NDVI, which is normalized difference vegetation index, or greenness index, and etc. And Level 3 data products are then generated from Level 2 data product, and usually these data products are in the form that we can easily interpret, and this can also incorporate it into other applications. And some example Level 3 data product might include biomass estimate for forest application, and we can also extract building footprint from this LiDAR data. We might be able to generate change maps so that we can do the change detection, or various other applications might be developed using this Level 2 data product you can see over here. Even though LiDAR data can provide unique information that other remote sensing technique cannot provide, there are several issues we need to consider to fully take advantage of this extremely valuable information. First, LiDAR data are big. Indiana finished 2 statewide LiDAR data collection cycles so far, and the first cycle was between 2011 and 13, and the second cycle was between 2017 and 2019. To give you an idea how big the Indiana statewide LiDAR data are, 2017 and 2019 Indiana statewide LiDAR data collection resulted in 15 terabytes of data. And 2017 and 19 data collection only included LiDAR data without any optical images. My research group is in the process of transferring 2011 and 2013 Indiana statewide LiDAR data, and we collected both LiDAR and aerial images in this cycle. And we can approximately estimate that 2011 and 2013 statewide LiDAR data collection to be somewhere around 30 terabytes because we have both LiDAR and aerial images collected in that cycle. In total, this is over 40 terabytes of data collected for this Indiana statewide LiDAR data collection, and these are a lot of numbers to store. In addition to the big data aspect of the LiDAR data, another big issue we need to consider is data processing software. Assuming that we spent a lot of time to download the big LiDAR data for your area of interest. Now, the next step is to play with the data you just downloaded. And LiDAR data are usually provided in LAS format, LAS format, and we usually need to have complicated software packages installed on the user's computer to visualize and analyze the data. We are now living in an era where diverse computing platforms are available. For example, I'm a Mac user, so I use a MacBook Pro with the OS X operating system installed, and I also use an iPhone and iPad with the iOS installed. There could be other users with a Windows operating system installed on their machine. And maybe they have a tablet with the Android operating system installed. And even worse, there could be other users with the Linux operating system installed. Having commercial software packages like ArcGIS could be a solution to this problem, but the commercial software packages require to pay expensive license fee to use it, and there could be many cases where the commercial software packages are not available in your computing platform. To address the two issues that I mentioned in previous slide, that is big data and complicated software packages, one solution could be developing an online data portal where users can easily access and analyze LiDAR data without downloading nor installing any complicated software packages. LiDAR data are stored in a centralized storage server, and users can visualize the data as a web service. We can also develop server-side application so that users don't need to install any software packages on their user side to analyze the LiDAR data. My research group, which is named as Geospatial Data Science Lab, and I call it the GDSL at Purdue University, has been developing such a data portal to host Indiana statewide LiDAR data so that public can access the LiDAR data very easily without downloading the big data or installing any complicated software packages on their machine. So let me demonstrate the Indiana statewide LiDAR data portal that my research group has been developing. So let me switch my screen to computer. So the URL to the Indiana statewide LiDAR data portal that my research group has been developing is lidar.jinha.org. Type enter. So the first page that you're going to encounter is data disclaimer, and this page includes information about the data source and what kind of license, and also it has information about Indiana 3D program, so that you can just follow the link to go to the IGIC story map website. And it also has information about USGS 3D program as well. And if you are curious about accuracy of the LiDAR data, you can follow this link as well. And I'm going to click OK to close out that window. Once you exit out of the data disclaimer window, now you will see a map of Indiana. And you can use your mouse wheel to zoom in and out, like you can see over here. Currently, you can visualize LiDAR point cloud for a certain location only. And you see this number 2. If you click that number, the map is going to zoom into a specific location that you just clicked, and you're going to see 2 markers being displayed. Once you move your mouse over to one of the markers, and another pop-up window will show up, and it will give you more information about the visualization tool that you can use. And it is saying that this is a Martech forest, and the data source of this visualization is 2017 and 19 Indiana statewide LiDAR data. And there is a link at the bottom says in a visualization tool. If you click that one, and another window will pop up, and you can see that this is a 3D point cloud data that you're just visualizing. You can just left click and turn around so that you can pan. You can use your mouse wheel to zoom in and out, as you can see over there. And if you zoom in enough, you're going to be able to see the individual trees. You can just turn around, and if you just right click and move your mouse, that's going to be pan operation, and left click and turn is going to be actually rotating your scene. You can see that some of the trees over here, there are some buildings over here. You can just turn it around to visualize this LiDAR data in 3D. Another cool feature of this visualization tool is now you can also only see specific point classes. So if you scroll down on the left window, and there is a classification tab. So let me collapse some of other menus so that you can see it. Right now it is showing all the point classes, but you can just turn off other classes that you don't like. And basically, Indiana statewide LiDAR data is provided in two different classes at this moment. And either they're going to be unclassified or they classified into ground. So you can basically see that these are all the point that is unclassified, and potentially this could be a vegetation or buildings, or you can just click that out so that you're going to be only seeing point that has a ground classifications as well. And as a matter of fact, these ground points are used to generate the digital terrain model. Okay, let me just exit this out. So another 3D point cloud visualization example that I made it available is in a Purdue campus. So if you just move your mouse cursor to another marker, pop-up window will show up, and this says that this is Purdue University data sources 2017 and 19 Indiana statewide LiDAR data. And if you click the link at the bottom, it says visualization tool. Another window will show up. And you can just do the same thing as in a previous example. You can use your mouse cursor, mouse wheel to zoom in and out. I can see over here. And you can use click right button and move your mouse to pan around. And you can just use left click and turn to move your turn the point cloud. So I'm just trying to find the building that I'm located, which is actually this building here. This is the Hampton Hall, where the Life School of Civil Engineering is located over here. You can just basically turn around so that you can see all those 3D point cloud structure are being visualized. So let me exit out of this tab. So these were example of 3D point cloud visualization. But what about if you want to download the Indiana statewide LiDAR data? And whenever you move your cursor over the counties, like I mentioned earlier, the name of the county is going to be showing up. And once you click the county polygon, and the name of the county is going to show up in the pop-up window, and there is a link. It says the LiDAR data download. So you just click that. Once you click the link, another page will show up, and by default, counties layers and tiles layer will be activated automatically. But you can always turn this off to see the county layers more clearly, and you can just turn on the tiles layer, and all those rectangle tile is the tile where you can download the LiDAR data. And let me just turn off the tile layer, because I want to show you another data product that is also available to visualize, which is NDHM, which stands for Normalized Digital Height Model. And this is a data product that is calculated from DSM and DTM, like I explained earlier. Basically, this represents height above ground. And once you click this layer, you're going to be able to see that this NDHM layer is being activated, and you can just zoom in, and all these different color map that represent the higher elevation above ground. And let me even just further zoom in, and this is in a Purdue campus, and this is in a Hampton Hall that you can see. You can see that some part of the building is higher than the other. You can see the individual trees are visualized very clearly using in this NDHM layer as well. And let's say this is how you visualize different LiDAR data product. But what if you want to download the actually data? So let me just turn on this NDHM layer. You can just move to any location where you want to download the data after turning on this tile layer. Let's say I want to download data over, for example, Wabash River over here. So this is Wabash River over here. I want to download the LiDAR data for this specific tile, and all you need to do is just click this tile. After you activate this in the tile layer, then it will give you option to download different LiDAR data product. And this one also has 2011 and 13 Indiana statewide LiDAR data available, so you can download the point cloud, or you can download the digital elevation model, or you can also download the orthomosaic images as well. Like I mentioned earlier in the presentation, this 2011 and 13 Indiana statewide LiDAR data is in the process of transferring from central another location. So this download link for 2011 and 13 may not necessarily work for the whole county. And if you go to the bottom of the screen, you're going to be able to see that we also have 2017 and 19 the Indiana statewide LiDAR data is also available, and you can download the point cloud data, or and DTM, which is digital terrain model. These are the two data products initially provided by USGS, but my research group also generated higher level products such as digital surface model and the normalized digital height model as well. And you can download this specific data product from this link as well. Let me just show you another example. So let's say, what if you want to download data from another counties? So let me go to another the town Bloomington, where we have Indiana University is located. We just move over to this Monroe County. You just click. In the same process as before, LiDAR data download for the specific county is being activated. Just click that. Just turn up the tile layer and activate this NDHM layer. Then you can visualize, normalize digital height model that is being generated from this 2017 and 19 LiDAR data. You can just zoom into the specific location, turn on the tile. You may have to zoom out a little bit to see clearly better the boundary of those individual tiles. If you want to download the data, you just click. We have a 2011 point cloud, digital elevation model, and orthophoto. Link is available. And the 2018, 17 and 19 Indiana statewide LiDAR data collection for this specific location, data was acquired in 2018. That's the reason why it is showing in 2018 over there. But you can just click and download the data set as well. Let's say you want to download the LiDAR data for this specific tile. All you need to do is just click the tile after you activate this tile layer on this window on the right, and pop-up window will show up and show all the available data product for this specific tile that you just clicked. And like I mentioned earlier, right now we have a menu for 2011 and 2013, and we also have a menu for 2017 and 19 data collection. And for 2017 and 19 data collection, for this specific location was flown in 2018. That's the reason why it is showing as 2018 over here. And you can download the LiDAR data. So let me just click to download. And it's going to be ask you to save file. So I'm going to be saving to my local disk. You can also download the digital surface model. I'm going to be saving that to file. And I can also download the digital terrain model. I'm going to be saving it. And I'm going to be downloading normalized digital height model as well. So I downloaded all those 4 data to my local disk. Then what you can do is you can just open up any GIS software. For example, I'm using Quantum GIS in this demonstration right now. So let me just open up the Quantum GIS, and I'm going to be moving this window. Okay, so let's just visualize the data product that we just downloaded. So let me just show an example of digital surface model that we just downloaded. So I'm going to be dragging that digital surface model over here, and you can see that some of 0 values showing up over here where we have no data. I'm pretty sure that is over the water, and this is a digital surface elevation. So this is elevation above ellipsoid. So that might be the reason why we are seeing a huge the range of numbers over here, but actually the most meaningful information is not going to be all the ranges over there. And you just overlay a normalized digital height model over here. You can see that now these ranges becomes much more reasonable from 0 to 125. Because this is data is in Indiana State plane coordinate with a survey foot. So unit elevation unit for this data set is in a feet. So if I just use a different color over here, give us pseudo color, invert color range here. Then this is how it's going to look like, and this is the actual elevation, digital surface elevation. Let me just use a different color over here. Use a different range over here, and probably let me just go to the histogram so that we can know the minimum value that we need to use is going to be somewhere around 700. So with that information, I'm going to set the minimum that I'm going to be using is going to be 700 and apply. That will give us kind of more realistic representation of elevation over there. This is the digital surface elevation, and this is actually normalized digital height model for that specific location that you just clicked. And if you go back to the download window, go back to Firefox, and this is the tile that we just clicked, and you can clearly see that this location that you just clicked is being represented in this data product that you just downloaded. So this confirms that you downloaded the correct data set. With that, I'm going to end my part of presentation, and I hope this presentation provides information on how you can access and visualize Indiana statewide LiDAR data. Thank you.
Good afternoon. My name is David Nail with the USGS, and I'll be presenting on the 3D elevation program, also known as 3DEP. The 3D elevation program is managed by the USGS and includes the contracting mechanism that was used in partnership with Indiana's state NRCS office to obtain high-resolution LiDAR for the state of Indiana. The goal of 3DEP is to complete acquisition of nationwide LiDAR by 2023, IFSAR in Alaska in 8 years to provide the first ever national baseline of consistent high-resolution elevation data for both bare earth and 3D point clouds collected in a time frame of less than a decade. 3DEP was designed to provide a 5-to-1 return on investment and a conservative monetary benefit of more than $690 million annually implemented in 8 years. 3DEP leverages the expertise and capacity of private sector mapping firms that acquire the data for the programs through the USGS Geospatial Products and Services Contracts, or GIPSI, and through partner acquisitions as co-op agreements. 3DEP will help all of its partners realize an estimated 25% cost efficiency gain by acquiring data in larger project areas, and of course will completely refresh our available national data holdings with consistent new LiDAR and IFSAR in the coming years. The 3DEP BAA, or Broad Agency Announcement, is the vehicle for soliciting partnerships with non-federal partners. It's a fair and equitable process that allows federal, state, local, tribal, and even private organizations to propose data acquisition projects. The status graphic that's shown on this slide reflects the current status of 3DEP data throughout the nation. The dark green areas represents the available or in progress data that meet the 3DEP specification, and the bright green areas represent fiscal year 20 LiDAR projects that have been awarded for contract. Planned projects are subject to change until they're under award. In this map, we've highlighted the fiscal year BAA awards in orange to emphasize projects that resulted from BAA submissions. The dark blue represents where the program has acquired IFSAR data in Alaska, which is now 100% complete. On average, BAA awards cover 30% of the total cost of the project with a range of 2% to 50%. In fiscal year 20, 26 out of 33 proposals were awarded in 17 states. In fiscal year 20, 3DEP project funding ranged from $15,000 to $2.5 million with an average award of $650,000. Project sizes ranged from 380 square miles to 18,000 square miles. What constitutes 3DEP quality data? The deliverables for any given project must conform to the most current published USGS product specifications for LiDAR and derived products using the most recent LiDAR-based specification, which can be found on the 3DEP website. The spec details how LiDAR projects must be acquired, from determining vertical accuracy to the classification scheme required for the LiDAR point cloud and everything in between. In addition to the requirements outlined in the LiDAR-based spec, LiDAR data and derived products will meet or exceed the current definition of Quality Level 2, QL2, as follows. Classified LiDAR point cloud data with a minimum point density of 2 points per square meter, a nominal LiDAR point spacing of no greater than 0.7 meter, and a relative vertical accuracy of no greater than 10 centimeter root mean squared error. When submitting a BAA proposal, the project location is an important criteria. The program's first consideration is to acquire data in geographic areas where no LiDAR data exists. The program will consider new acquisitions if the LiDAR data is older than 8 years, resolution is quality level 3, 4, or 5, or if the proposed acquisition covers areas over which significant changes to the landscape have occurred. The program also looks at aerial extent. The program prefers projects greater than 1,500 square miles. Scores for this criteria increase as the project size increases. The number of awards in any given fiscal year is based on the amount of funding, and the government will review proposals based on the project's alignment with the evaluation criteria identified within the solicitation. Awards will be first offered to those proposals receiving the highest score, and the government will continue to offer awards to other candidates whose proposals received favorable scores based on the availability of funding. The program will consider projects outside of this range to fill in gaps in coverage or for projects that bring considerable funding, i.e. large cost share, to the table. 3DEP is a call for community action because it's an effort to address more than 600 mission-critical needs reported by 34 federal agencies, 50 states, and a sampling of other organizations that were documented in the National Enhanced Elevation Assessment of 2012. Many of you may be participating in the current 3D Nation Requirements and Benefits Study, which is designed to determine elevation needs from our highest mountains to our deepest oceans. The USGS National Geospatial Program uses this information to assure our programs continue to satisfy the needs of our nation for high-quality, enhanced elevation data. Here is a list of online resources regarding 3DEP and the BAA process. Thank you, and I believe there will be a time for a few questions at the end of this presentation.
Good afternoon. My name is Joan Keene, and I am the chair of the IGIC Elevation Work Group. Today I would like to share with you the Indiana Statewide LiDAR Planning and Status Story Map, which was created by Phil Worrell. The story map can be found on the IGIC website by going to the Committees and Workgroups tab, and again on the Elevation Workgroup's link. The IGIC Elevation Workgroup is responsible for Indiana statewide LiDAR planning. The group identifies local, regional, and statewide elevation stakeholders, determines their elevation data requirements, and adapts appropriate elevation standards to meet those requirements. At the request of the GIO, the workgroup supports the GIO in the development of request for proposal elevation projects for the state of Indiana. A link to the story map is included at the bottom of the workgroup page. The story map opens with an introduction to LiDAR and 3D elevation program or 3DEP initiative. As you can see, you can scroll using both the left and right panel of the screen in order to provide information about the topics. The story map also includes information about the USGS National Enhanced Elevation Assessment, the USGS and NOAA 3D Nation Study, the USGS 3DEP BAA process, and NISGIC's 3DEP for the Nation State Plan Initiative. IGIC's Elevation Workgroup maintains an inventory of existing elevation data, recommends update cycles, identifies data sharing and distribution mechanisms, and provides education and outreach on data uses to stakeholders and the public. This plan is also seeking new LiDAR areas of interest. If you would like to provide your area of interest, you can do it in 3 different ways. You can take our AOI survey by filling out the form. Choosing your 3DEP topographic LiDAR quality, inputting an address, and submitting that survey. You can also draw your AOI on a map use the Smart Editor tool to draw a polygon. Fill out the form and submit it. Or you can simply provide your contact information and we will reach out to you. Indiana's 3DEP plan includes a multi-year acquisition plan. Indiana's statewide LiDAR acquisition began with the 2011 to 2013 cycle. Starting in 2014, IGIC's Elevation Workgroup began to design and implement Indiana's new 3DEP plan. For fiscal year 16 and 17, IGIC initially submitted a BAA cooperative agreement proposal to USGS that focused on 6 counties in northeast Indiana. Funding partners included Indiana's NRCS office, county government partners, and a request for the remaining funds from the USGS 3DEP program. This project was selected by USGS for a BAA award But before this contract was signed, the Indiana NRCS office was able to budget a total of $6.625 million to expand our original BAA proposal to be statewide. As a result, the Indiana office of the USDA Natural Resource Conservation Service, or NRCS, expanded their area of interest statewide in agreement with the USGS to fund the collection of new LiDAR data products for the state of Indiana starting in 2017, with the current scheduled completion date of late fall 2020. The acquisition status is as follows. The USGS has contracted with Wolpert for this new statewide LiDAR data to be developed under the USGS's 3D elevation program to deliver QL2 LiDAR data across Indiana, consisting of 2 laser pulses per meter spacing, a 2.5-foot bare earth hydroflattened digital elevation model, and a 2.5-foot pixel intensity image generated from the LiDAR pulse's surface reflectance. Deliverable products include LiDAR tiles, individual tiles in LAS 1.4 format, DEM tiles, individual tiles in image format, intensity data tiles, individual tiles in TIFF format, DEM mosaic, merged county-wide DEM mosaic file in image format, and county-wide delivery tiles in GIS shapefile format. Once the project is complete, final project metadata and reports will be produced and provided. This new 3-depth LiDAR data is now in the process of being acquired, processed, reviewed, accepted, and delivered to Indiana's NRCS office by USGS. After each final county LiDAR data set is delivered to NRCS, and on behalf of NRCS, IGIC is making and distributing copies of this new public domain elevation data to the state of Indiana, to each county, to Indiana Map, and to the Indiana Spatial Data Portal. As of April 2020, new 3-depth LiDAR base products for all but 8 counties in southwest Indiana have been delivered. Overall goal is to complete work on all of the remaining county data by the late fall of 2020, followed by the release of final project metadata and accuracy reports for the entire project. Next steps include maintain Indiana LiDAR data on a refresh frequency of no more than 8 years, realize new benefits and reduce costs through emerging elevation data technology, develop new statewide derivative products from Indiana's new 3-depth LiDAR data, utilize new 3-depth LiDAR data to classify roofed buildings of 10 foot by 10 foot or larger within the data and extract building outlines, and investigate other types of elevation data and technology for Indiana, such as terrestrial LiDAR, bathymetric LiDAR, and UAV-derived elevation data. If you have input for the Indiana statewide LiDAR data, please contact lidar@igic.org. Thank you.